Hello everyone and welcome to today's mathematics session. Today, we are going to revisit one of the most famous concepts in geometry, the Pythagorean theorem. However, we aren't just going to memorize the formula. We are going to look at a specific, very elegant proof that comes from ancient Chinese mathematics, developed by a mathematician named Zhao Shuang in the 3rd century. First, let's make sure we are all on the same page regarding the theorem itself. By definition, a right triangle is a triangle that has one 90-degree angle. The side opposite that right angle is called the hypotenuse, and the other two shorter sides are called the legs. If we label the legs as A and B, and the hypotenuse as C, the Pythagorean theorem states that the square of the length of the hypotenuse equals the sum of the squares of the legs. In other words, A squared plus B squared equals C squared. Now, let's look at how Zhao Shuang proved this nearly 2,000 years ago. His method is purely geometric and visual. Imagine constructing 4 identical right triangles. We arrange these 4 triangles to form a large outer square. When we do this, the hypotenuses of these triangles form the sides of the empty square hole right in the middle. Before we calculate the area, I want to pause here. I will leave this as a question for you to think about. Why exactly is this inner quadrilateral, which is surrounded by the 4 hypotenuses, definitely a square? It is worth considering the angles to convince yourself that it is indeed a perfect square. To prove the theorem, we calculate the area of this large outer square in 2 different ways. First, we look at the side length. The side of the large outer square is actually the sum of the 2 legs of our triangle, which is a plus b, so the area is simply the quantity a plus b squared. When we expand that algebraically, we get a squared plus 2 times a times b plus b squared. The second way to find the area is to add up the individual pieces. The large square is made of 4 triangles and that one small inner square. The area of each triangle is 1/2 times base times height, or 1/2 a times b since there are 4 of them, that totals up to 2 times a times b. The small inner square has a side length of c, so its area is c squared. Here is the magic moment. Since both expressions represent the exact same total area, we can set them equal to each other. We have a squared plus 2ab plus b squared on one side, and 2ab plus c squared on the other side. If we subtract the term 2ab from both sides, they cancel out perfectly. We are left with the famous result, a squared plus b squared equals c squared. This proof is beautiful because it relies on basic area formulas and makes the relationship immediately apparent without needing advanced calculus. That wraps up our look at the Pythagorean theorem for today. Thank you for listening, and I will see you in the next class.